have some rules and principles which need to be discussed. Why some rules and principles need to be discussed? Because what is strange and surprising to me even now is basically when you cut open the atom, right? If I give you 100 electrons in your hand and ask you to distribute that inside the atom, you can't do it randomly. There is absolutely nothing random here. In fact, I would like to say the randomness is zero. So I can say that the randomness is absolutely zero. If I give you 100 electrons and ask you to put them in an atom, you can't throw everywhere, the way you like it. You must understand this, right? There is absolutely no randomness inside the atom at all. And what is surprising to me, really surprising, really surprising, is there exists absolutely regular arrangement. There exists absolutely regular arrangement inside the atom, whether it is within the nucleus or even outside the nucleus. In fact, I can say the atom can be divided into a nuclear part and the extranuclear part, what we call. The nuclear part is that which is inside the nucleus, and the extranuclear part is that which is outside the nucleus where the electrons are revolving. Well, I would like to claim, and it is so surprising to me, it is absolutely so surprising to me even at this stage to understand that there exists a regular arrangement and the randomness is absolutely zero. For your understanding, I wanted to say that if I ask you to actually place some electrons inside the atom, giving you 100 or 200 electrons, you have to follow some rules and regulations. You must understand rules and principles. You must understand that, right? So what my claim about this is there exists. That's a symbol for that. There exists, right, regular arrangement. There exists absolutely regular arrangement. And in fact, I would like to quote the randomness. Randomness is absolutely zero. The randomness or the disorderness is absolutely zero. There is a regular arrangement. It's really surprising. It's really surprising. The atom is invisible, but still there is regular arrangement within the nucleus. I would like to claim even within the nucleus an extranuclear part that is outside the nucleus with respect to the electrons, and we are dealing with the extranuclear part and the distribution of the electrons. You must understand that, right? If that is the case, the first rule or the principle which I would like to quote is the Hund's rule, the Aufbau principle first. Aufbau's principle, right? And the second one which I would like to claim is the Hund's rule. And the third one is the Pauli's exclusion principle. You must understand. Right? You have some rules and regulations. Now why all this is cropping up? Please understand that there exists a regular arrangement, no randomness. In fact, the randomness inside the atom is absolutely zero. So if there is no randomness, there is something which is in order. And when there is an order, there should be some principles and rules which are fixating that, right? And some rules which I would like to quote for you is, of course, the Aufbau principle, the Hund's rule, and the Pauli's exclusion principle. Let's take one by one. And I'm again reminding you the critical thing that there exists absolutely zero randomness, zero disorder inside the atom. That's why we are worried about, how to actually, is there a scheme of distribution of electrons? Is there a scheme of distribution of electrons? Of course there is a scheme. The scheme will come into play because there is absolutely no randomness and there is a regular arrangement. You must understand that, right? So if I can quote it to you, it's the Aufbau, the Hund, and the Pauli which we would like to discuss. Let's take up first the Aufbau's principle and let's see some of the deviations also what we see in this. And I draw the attention of everyone now, right? Observe carefully here, the Aufbau. The Aufbau's principle. Right, now what is Aufbau? Aufbau is not a person's name. It's not a person's name, mind you that. Aufbau is just a German word which is saying it's a hierarchy. It's basically a hierarchy and it's not anyone's name or a noun. You must understand that. It simply says building up. That's all. It's building up rather. Right? And I was telling you quantum numbers, so we'll use that while framing the Aufbau principle. And what it basically says is, look into this scheme what I'm writing here. When I write here, it will be a combination of integers. It will be a combination of integers and SPDF blocks. Right? And if simply it's an integer, it is a shell. and the integer combined with SPDF is a subshell. So what I'm writing in Aufbau principle is basically subshells. Now, why all this discussion? I would like to remind at every point to you. I want to remind you at every point of my discussion to you, because there exists a regular arrangement and no randomness. When there is a regular arrangement, there must be a scheme. There must be a scheme. And when there is a scheme, I think you have to follow that scheme. And one of the first schemes which I'm quoting is the Aufbau principle. And look into the sequence in which I'm writing. Watch carefully here. Watch carefully here. So if I can write, this is 1s. Now what did I write? If I ask you, what did I write? It's basically a combination of a number along with s. So a combination of a number along with s is basically a subshell. So what is 1s? If someone is asking you, the answer must be it is a subshell. What is 2p? It's basically nothing but again a subshell. What is 4s? It's a subshell because it's a combination of an integer and SPD. We call this to be what? Subshells. You must understand that. So if I can write it, so this is how the scheme is. Watch carefully here. This is 2s, this is another subshell, right? And this is 3s, and this is 4s, and this is 5s, and this is 6s, and this is 7s, and this is 8s. You must understand. I am not going beyond 8. There is a reason for that. There is a reason for that. Well, if you remember, I was drawing the spectra, and in the spectrum, what you see, these the lines, and that's nothing but the slit image which passes through the spectrophotometer. So remember that, I am restricted to only 7th or 8th shells. What happens after 7th and 8th is each line merges with the other. So when we are speaking of hierarchy, what is Aufbau? Aufbau is nothing but the hierarchy. It's basically the hierarchy. It is basically the hierarchy or just building up. So when someone is telling about hierarchy, the lower one first and the higher ones the second. Now, after 8 is what's happening is this hierarchy has no meaning at all. This hierarchy is absolutely having no meaning. You must understand. If there is no meaning at all, then, that means that the 7s, after 7s, 8s, 9s, 10s, or you have infinite number of what? Subshells. And all these are merging with the another. I can draw here. If I say this is 7, that itself is 8, that itself is 9, that itself is 10, that itself is 11, that itself is 12. So each line is basically merging with the other. So when each line is basically merging with the other, I call this to be a band. I call that to be a band. So when there is a band, the question of hierarchy, the question of building up from the lower to higher, I think it ceases to exist after 7th energy level. That's why in periodic table also we have only till the 7th energy level. Beyond that we don't have, even though you have infinite number of what? Orbits in an atom. You must understand that. So I want to make it clear, why did people write it? This is a basic question what people might ask you. Why did you restrict yourself to 7 or 8? If someone is asking. Well, in process of filling the electrons from lower to higher, when you're saying lower to higher, that the scheme is involving a hierarchy. The scheme is basically involving a hierarchy. And the hierarchy will play a role only after certain energy levels. If you look into the energy equations, which I was proposing to you, you can look there that the energy difference between the subshells is continuous, energy difference between the shells is continuously decreasing, and the delta E was tending to 0. You must understand. The delta E is tending to 0, and the delta E tends to 0 after 7th or 8th subshells. I think you can't distinguish this, and they look like a band. So the question of speaking in terms of hierarchy or building up doesn't exist after the 7th energy level. You must understand that, right? So that's why I restricted myself to only to the 7th or 8th energy levels. You can put it to infinity. After all, you have infinite number of what? Shells in an atom. But restrict yourself to 7 or 8, and after that it looks like a band, right? So then what you do is, the scheme is you leave the first one and then just write 2p, 3p, 4p, 5p, 6p, and the 7p. And look into this. That's how the p orbitals are, the p subshells are. Now what I'm writing, what are all these? These are nothing but subshells. How do you distinguish a subshell? It's basically an integer and the SPDF combined together is called subshell. So basically what I'm writing, all these are nothing but what? Subshells. You leave one gap at the top, at the bottom. That's how it's an easy scheme of what? Remembering. And then what you do, leave one more gap. This is 3D, 4D, 5D, and 6D, and leave a gap. Right? So that's about the D. and then leave again a gap, and this is 4f and 5f. You must understand that. So what is that you have written on the board is basically nothing but a combination of numbers and SPDF, and these represents what? Shells. You must understand that, right? So what is the hierarchy now which you need to follow? What is the hierarchy? Like for example, if you are given 100 electrons in your hand and ask them to place in the subshells, because there is a regular arrangement and there is absolutely no random arrangement. In fact, the randomness is almost zero. Rather, in thermodynamic terms, what we call is the entropy is zero in an atom. Entropy is a measure of disorderness, and the entropy is zero. The disorderness is zero. The randomness is basically zero. So the electrons are placed according to a scheme, right? According to a scheme. And look into the scheme. What I will do is first fill the 1s. Because this is of the lowest energy subshell. So what is basically Aufbau telling is, it's basically telling fill first lower energy subshell. Then what? Then the higher energy subshell. That's what is his claim. Not his claim. It's basically telling building up. He's not a person. It's a German word. That's nothing but filling up. Aufbau is not a person, mind you. Don't say he or she, right? And remember that fill first lower energy subshell, then the higher energy levels are what? Filled up. And the lowest energy is 1s, so I filled it first. And then comes this. Then it is 2p and 3s. And this is 3p and 4s. And this is 3d, 4p and 5s. And 4d, 5p, 6s. And this is 4f, 5d, 6p and 7s. And this is 5d, 6d, 7p and 8s. You must understand. So first fill 1s, then go for 2s, then go for 2p, 3s, and then 3p, 4s, like that. Is it my dream? Is it my wish? Is there a basis for this filling? Of course, there is a basis for filling. That's nothing but the energy, and the lowest energy is filled first. Then we are going for the highest energy. That's how the Aufbau principle is. You must understand that. Right? That is a basic structure of what? Aufbau principle, where you can write your electronic configurations. For example, if I wanted to write the potassium configuration, which is 19. Suppose if I wanted to write the distribution. Configuration is what? Configuration is nothing but the distribution of electrons. That means basically in potassium I gave you 19 electrons. Total 19. I gave it in your hand and asked you to distribute in that atom. You can't throw in one in some in this corner, that corner. It's not your wish. There is a scheme. And the scheme is basically followed, and it's actually determined by the Aufbau principle, the way the energy levels have been filled or the subshells have been filled, and you must be following it. So that's nothing but the electronic configuration. So the electronic configuration, the basis is what? The Aufbau principle. So if I give you 19, everyone must follow this. So first follow the sequence. It is 1s. So 1s is first, then 2s, then 2p, then 3s, then 3p, and after 3p, you can see 3s, 3p, and then we go to 4s, right? And s can accommodate a maximum of 2 electrons, so it is 2, this is 2, 2p6, 3s2, 3p6, and 4s1. This is how the hierarchy has been followed using what? Aufbau. These things you are told in your high school classes also, you must understand that, right? You must understand that, right? And what we need to do, what are the questions, what are the applications of the Aufbau principle? You must be knowing it, right? Well, I write some of the applications of the Aufbau principle, and and that will be some of the questions for JEE mains or the NEET exam which you will be writing, right? Well, I would like to link this Aufbau principle to those questions. Well, first of all, people who are listening to this lecture, what is the use of what? Why did you propose Aufbau principle in the first place? Why did you propose the Aufbau principle in the first place? The reason why I am proposing the Aufbau principle in the first place is, first of all, there is a regular arrangement inside the atom. And I would like to extrapolate and tell you that there exists a regular arrangement even inside the nucleus. Forget about the extranuclear part. There exists a regular arrangement inside the nucleus and outside the nucleus also. And outside the nucleus is where we are focusing on. So when you have a regular arrangement, you should follow some rule. You should follow some scheme. And what is the scheme? On what basis the scheme has been framed? And let me tell you that this is Aufbau, and it is framed basically on the hierarchy of the energy levels. You must understand that. So, if you see in this Aufbau principle diagram, all these are basically subshells. All these are subshells, and each subshell is filled in a schematic way, in a ruled way, in an arranged way, right? And the lowest is filled first and the highest is filled first, and if anyone is following this hierarchy, we call that configuration to be the electronic configuration or the electronic distribution within the subshells or within the shells. That is why is the reason we are discussing what? Aufbau principle. Now, what is the applications of Aufbau principle? One by one I would like to quote it. I draw the attention of everyone now. Watch carefully here. Watch carefully here. What are the applications of what? The Aufbau's principle you must understand, right? First of all, understand. There will be, I'm claiming this, and I'm not surprised while I'm claiming this. Well, I'm not at all surprised when I claim this. Well, understand, there will be violations of Aufbau. There will be violations of Aufbau. You should know the reason, and where exactly are the violations is the questions in exam. Are the questions in exam. Now, where do we find violations first of all? Where do we find violations? Remember, why do we find violations? First of all, as we move away from nucleus. If you remember and recollect one of the lectures, what we are doing in Bohr's theory, if you look into it, right, as we move away from the nucleus, then the energy difference, delta E, what I call the energy difference between any two energy levels, E2 minus E1, right? So the energy difference is basically tending to zero. I won't say it is zero. No one can claim it is zero, but I think it tends to zero, it's closer to zero, right? When the energy difference between the shells is tending to zero, then I can simply say energy difference between the subshells also tend to zero. Or become less rather, or becoming less. So in this process, what I'm doing is, when you are going far away from the nucleus, that means that the first, second, third, fourth, you're not getting any violations. You're going for the first energy level, then the second energy level, then the third energy level, etc. Like it's almost like a climbing a steps. When you actually, when you say you're climbing the steps, you should understand the first is the lower, the second is, and you are carefully climbing up. But when you climb up to a certain extent, right, the steps gap actually decreases. When the gap decreases and almost tending to zero, then you're rather walking. You're not actually stepping onto the steps. You're not going onto the steps. So if there is no difference between the step and the step, you're basically walking. That's what exactly happens even in an atom. Mind you that when you are going far away from the nucleus, please understand that the energy difference between the shells decreases. And the energy difference decreases, the energy difference between the subshells also decreases. Right? Well, I would like to tell you some of the violations. Then what happens is, when the energy difference decreases, when the delta E tends to zero, then violations of Aufbau is obvious. Is absolutely obvious. Right? There is no surprise in that. Well, I would like to illustrate this for you. And watch carefully, I wanted to write some of the electronic configurations for you, and I will show you the violations. Look into this, some of the electronic configurations which I am actually writing it for you. Watch carefully here. If you actually see scandium, titanium, vanadium, chromium, manganese, iron, right? Some of the elements which I am writing. And if I can write its configurations, these configurations to you, scandium, titanium, vanadium, chromium, manganese and iron, well, scandium is 21. It's 21 is its atomic number, so it is 4s2 3d1, the outermost electronic configuration. It's 4s2 3d1, right? 4s2 3d1. And then titanium will be 4s2 filled first and then 3d1. Watch carefully here. This is 4s is being filled first and then 3d1. There is absolutely no violation. We are following the Aufbau principle. And if you see the 21 configuration, if you do it from 1s1, 1s2, 1s3, 1s2, right, following the sequence, you will end up with 4s2 3d1 for scandium. And for titanium, it's 4s2 3d2. No violation. Absolutely no violation. After 4s, you need to fill 3d. It's absolutely no violation. And then vanadium, if you see, it is 4s2 3d3. No violation. No violation. Right? And then if you come to chromium, I draw the attention of everyone. I draw the attention of everyone, please, who is listening to me. Right? I draw the attention now. Watch. The next we expect this to be 4s2 3d4. This is the expectation. This is the expectation. After all, we will expect, because we are following the scheme of Aufbau. We are basically following the scheme of Aufbau. Right? So naturally what will happen is, after 4s, you are supposed to go to 3d and you are filling the fourth one. You are filling the fourth one. Right? But this is the expectation. But the actual configuration, if you see, it is basically 4s1 3d5. Come on. Come on, man. This is what you need to watch. This is what you need to watch. This might be a question in your intermediate exam, but mind you, you might have not asked this question, why such a thing would be happening. Why such a thing should be happening to your teacher, right? So, if we follow Aufbau principle, it's 4s2 3d4, 4s2 3d4, but actually, in practice, it is 4s1 3d5, 4s1 3d5. That means that we can actually say one of the electron from the 4s subshell is shifted to 3d. One of the electron from 4s has shifted to 3d. And I want to ask myself, how dare it can be doing like that? How dare you can do it? That's a question. Because we are following a rule, we are following a scheme. Remember this, when an electron is basically shifting from one subshell to the other, that indicates that it is an easy shift. It's basically an easy shift. Otherwise, why would I anyway see? If I am in the first step, I wanted to get into the 8th step, it would be difficult for me. Because in between there are 7 steps and it is absolutely difficult for me. But if I am able to climb up from the electron is moving from one subshell to the other, that means that I can simply write this. If this is happening for chromium, which is expected is 4s2 3d4, this is expected, but in reality, I think it is 4s1 3d5. In reality, it's 4s2 3d5, sorry, 4s1 3d5. That's because I think the energy difference between 4s and 3d is basically 2. I would like to add 2 more O's. 2 more O's. Too small. The energy difference is too small to consider the Aufbau principle. See, when an electron is freely traveling from one subshell to the other, then naturally the energy difference between the subshell is too small. It's very small. That's why an electron is able to cross from one subshell to the other. So, it's a clear violation of Aufbau, because when we started Aufbau, we told that there is a hierarchy and the basis of Aufbau principle is basically what? Basically nothing but what? The energy difference between the subshells, and that's how the hierarchy has been followed. But if there is violation in configurations like this and the electron is shifting from one subshell to the other, then it's a clear indication of Aufbau principle's violation. Well, I have one other violation also, there is another violation also. And if you look into this, there is another violation which I would like to quote here. If you like to write copper, which is 29 is its atomic number, then it is basically 4s2 3d9. 4s2 3d9. This is the expected configuration. This is according to Aufbau. That's according to Aufbau. Theoretically, that's theory. But practicality, if you look into this, the actual configuration is basically 4s1 3d10. One electron being shifted to the 3d. Now this question we would have asked our class teacher when he or she is explaining to us. If you have asked, it's fine. But common sense is telling you when electron is able to shift from one subshell to the other subshell, because this is one subshell, that is the other subshell, when it is shifting from one electron from one subshell to the other, I think the only difference might be because the energy difference between the subshells is too less. Too less. In fact, it's tending to zero. And remember, we are in the fourth shell. That means when you are moving away from the nucleus, first, second, third, and the fourth. When you are moving away from the nucleus, the energy difference is decreasing, and whenever you cross that fourth shell, fifth, sixth, and go to this area of what? The lanthanides and actinides, you will be finding total violations of Aufbau. Total violations. In fact, I think you can feel the violations starting from what? Chromium and copper, and it will continue further. When the electron is being filled in the 5th, 6th, 7th energy levels, the energy difference further becomes zero, and the question of Aufbau principle, theoretically it remains theoretically, but practically you can see that the energy difference falls, and there is absolutely no scheme in following the Aufbau principle. You must understand that. Right? That's the first question which I wanted to explain. Second question what I wanted to explain is this one, and watch carefully here. Watch carefully here. Why? Watch carefully. So basically, what is the answer? What you would like to write? Well, I would like to write this question. Why chromium and copper violate Aufbau? Why do they violate Aufbau? Right? And if it is chromium configuration, rather is 4s1 3d5, and copper configuration is basically 4s1 3d10, and you can see the shift. So I can simply say the energy difference between the 4s and the 3d, basically between the 4s and the 3d, is too small. Too small to follow what? The Aufbau. Hence violation. Hence violation you must understand. Hence the violation you must understand this. So why all this is happening, if I can recollect, if I can actually recollect to you, well, understand there is an energy equation which I proposed. The energy equation proposed by Bohr, that is 3.6 by n square electron volts. That's what is the energy equation, the cute equation which was proposed to you. Right? And if I can find out E1, that is minus 13.6 by 1 square, minus 13.6 by 1 square, that is minus 13.6 electron volts, right? And suppose if it is E2, then it is minus 13.6 by 2 square, that is minus 3.5 electron volts, right? And if I can find E3, then that is minus 13.6 by 3 square, that is minus 1.5. Now look into the energy difference, what is happening. The energy difference between these two, that is E2 minus E1, is basically 13.6 minus of minus 3.5, that is coming to plus 10.2 electron volts. This is the value, plus 10.2 electron volts. If I actually go between these two, which is E3 minus E2, then it is minus 1.5 minus of minus 3.5, that is plus 2 electron volts. Watch carefully here. Now when I am actually going for the energy differences, then first is 10.2, then it is 2, then you can go for E4 minus E3, it further decreases, and you are going far away from the nucleus. I think the energy difference is basically delta E tending to 0. Tending to 0. And when Aufbau is claiming that the distribution of electrons, the basis is the energy hierarchy, lower energy levels first and the higher energy levels first, I think it's fine for the first energy level and the second energy level because you have 10.2 electron volts difference. And even it is fine for third to second because you have 2 electron volts difference, fine. And then go further, I think it is equal to, further decreases. You have some value, you have some clear values, well-defined values, you must understand. But as you move away and go to the fourth shell, I think you have started violations in Aufbau in the form of what? Copper and chromium. And when you go for the sixth shell or the seventh shell, where the lanthanides and actinides are basically placed, you find total violations of Aufbau principle because you're almost far away from the nucleus and the delta E is almost what? 0. This is even reflected in the spectra. This is even reflected in the spectra. And if you look into the spectra also, if you basically look into the spectra, right? This is the first energy level. This is the line. This is the line spectra. That is the first energy level. And the difference between the first energy level and the second energy level is 10.2. So you have a gap between these two. You have a clear gap. When you have clear gaps, I call these lines to be well defined. We call this to be what? Well defined lines. And then if you see the third one, the gap further decreases. Right? The gap decreases. And then the fourth line, the gap is further decreasing. Right? And the fifth, actually, you can see here, that is the fifth. And that is the sixth. Come on. And that itself is the seventh. Hardly you can see anything. And that itself is the eighth. That itself is the ninth. That itself is the 10th. That itself is the 11th. Like that, infinity. You must understand. The band appears. The band, this is like a band. And then you have well-defined lines only to certain energy levels. Violations start kicking in. Violations start kicking in from the fourth energy levels itself, because you can see the copper and chromium being what? Violated in their electronic distribution, where the Aubert principle is what? Violated. And then if you go for the lanthanides and actinides occupying the sixth energy level and the seventh energy levels, you can find everywhere violations, because the hierarchy is absolutely not followed, the scheme is not followed. And that's what I say the Aubert principle is what? Violated. Well, I hope you understood this. Right? And then we will be discussing the Pauli's exclusion principle and Hund's rule. Right?